This is chapter 5.4 of Z transform. In this chapter, we're going to focus on how to use the Z transform, and in particular, we're using Z transform for constant coefficient difference equation to represent discrete time, linear in time invariant system. These are the details of the subsections in this chapter. Let us begin. What is a constant coefficient difference equation? As its name implies, the constant coefficients are the coefficients we're talking about is here, A case and B case, where y is the output, especially y at time n, and x are the input, until xn minus k. Typically, our system is focusing on only causal system, so we are not going to use future values. Although future values are possible in this equation, we're not going to use future values of the output as well as the input. Let us write this equation down for a0 y of n minus 0 plus a1 y of n minus 1 plus a2 y of n minus 2. Let's just consider that we only have this n equals to 2 problem is equals to b0 x of n plus b1 x of n minus 1 plus b2 x of n minus 2 plus b3 x of n minus 3, and we stop here for m. Now let's also assume that we are going to let a0 equals to 1 first, and if a0 is not equals to 1, we divide the whole equation by a0. Alright, and then therefore we have y of n minus 0 equals to, we'll bring all this equation down to the right hand side. So we have b0 x of n plus b1 x of n minus 1 plus, then we are going to also bring those things on the left hand side from these two yn's. So what we have is that we have yn, so we can ignore the 0, so it's yn equals to some summation of xn and his past value, and some summation of yn and his past value multiplied by a's for y and b's for x. And it's constant coefficients because all these coefficients that is multiplying the x and y, they are constant, so it's constant coefficient, and this is difference equation because the b's can make it plus or minus. When this system is described like this, the system can be shown that it will be linear and time invariant if when we begin, all the x's and all the y's in memory are set to 0. So when n is 0 and all this memory is 0, then y will be 0. You can then also show that the system is linear and time invariant. We shall not prove. For proof, you can see octet and alkene at this page 201 from this book. Alright, now we have a linear time invariant system, discrete time, and described by this equation. So what can we do about it? Please go to the next page.